Polynomial review. The first four, just adding and subtracting polynomials. So it looks like there's not even coefficients out in front. You know, if there was a coefficient, like if this was this function plus 2 times this function, we'd have to distribute. But it looks like the only thing we have to do, like when you have a minus, if you're taking this polynomial minus this polynomial, you do have to distribute that negative sign. You'd have to distribute that negative sign to those three. But other than that, the parentheses aren't doing anything, and you're just collecting all the terms. You know, when you look at this first one, you're looking at 2x cubed plus 5x cubed to give you 7x cubed. The squares, well, it doesn't have any partners, so it's just it. And then the constant with the constant to give you the plus 2. And then you do the same thing for all of these. So we're just adding and subtracting using like terms, and then we will put it into standard form, which means we have our cubic and then our quadratic. And for whatever reason, all of these look like they have a cubic term, a quadratic term, no x term, and then constant. And that's just random. 5 and 8, we're going to multiply. So we're going to distribute the 2x squared times this, and then times this, and then times this. And then we're going to take the negative 3 times this, and this, and this, and you're going to end up with 6 terms. If you have a binomial times a trinomial, you're going to end up with 6 terms, and then you just have to group them. So in this one, we're going to take our squared term there with our other squared term there, and then everything else doesn't even have a partner. And so we just write them in order of decreasing. So start with x to the 5th, x to the 4th, x cubed, x squared. And if there were x's, which there aren't in that one, and then the numbers, which is the constant. Same thing here, except this is a little more complicated because it's a 3-term, a trinomial times another trinomial. So go ahead and distribute the 3x squared here, here, and here. And then the x, boom, boom, boom. And then the negative 2, boom, boom, boom. And you end up with 9 terms. And then just be careful to collect all the like terms together and then write it in the standard form. This is a 2 by 3, very similar to the one right above it. Take the x. So the x times the 4x squared times x times minus 2, that gives you your first 3, and then distribute the 2 here, here, and here, and then combine like terms. Same thing here. It's just a binomial times a binomial, so people use the word FOIL, but all of this is just multiplying polynomials by distributing. So this isn't anything different. People use the word FOIL for first, inner, outer, last, but it's just the same thing. Take the 2x times x and the 2x squared times the 1, and then negative 6 times the x and the negative 6 times the 1. You get 4 terms, nothing to combine, so you're kind of done. Okay, you got a leading coefficient, so you got to make sure they're written in order, which they are. And so the leading coefficient here is 10, which means if it's a 10x cubed, it generally would look like this. Now remember, the size of the humps and the location of the humps are all about the details, but the general shape of the function is completely based on the big dog. So a positive x cubed is going to look something like this, and we call it a cubic, and it is degree 3. Over here, when you rearrange it, it is degree 4 because of the x to the 4th. The leading coefficient is a negative 4. We would call it a quartic because of that degree, and then it generally looks like an m since it's a negative x to the 4th. Okay, and here, sketch a quartic function with 2 real zeros. So I need to sketch something that looks like a W, so up and down and up and down, and it's going to have a max and a min like it says, and it looks like it has 2 x-intercepts, so it's going to go here and here. So make sure when it has this minimum it doesn't actually go through again. So it's going to have 2 real zeros. It would end up having 2 imaginary zeros as well. We know that the number of zeros, real and imaginary, have to add up to the total of the polynomial, and since it's a quartic x to the 4th, it's going to have 4 things. In behavior, both left and right both go to positive infinity because this positive quartic goes up. Okay, here's a cubic function with 1 real zero, meaning 1 x-intercept, and it's got a max and a minimum, so it's going to go like this general shape, and it's going to have this as a max. There's our min, and there's our 1 x-intercept, and so if it has 1 real x-intercept, it does have 2 imaginary, because 1 plus 2 is 3, and we do know it has to have 3 total, considering it's a cubic. And behavior, well, as you go way to the left, what's the function doing? Well, it's going way down. And as you go way to the right, the function is going way up. And so that's how we talk about those. 13, we talked about in class, so you got to delete that little piece right there. Sketch a cubic function with 3 real zeros. And so this one looks like it's going to be a negative cubic because it's got to go down and have this minimum, and then up from x, and then down. And so in this case, it goes through the x-axis 3 times. So it has 3 real zeros and no imaginary. And behavior, as you go to the left, it goes up, and as you go to the right, it goes down because it's a negative cubic. Sketch a quartic. So this has 4 real zeros. So this goes up and down and up and down, and it goes to the x-axis 4 times. So it's got 4 zeros. It's got 2 maxes and a min, and so it would be a negative cubic, or excuse me, a negative quartic function, like a negative x to the 4th. And then both end behaviors are negative because on the left and the right they both go down. We just look at this first part. So match the functions to the graphs. And so remember, the big dog determines the shape, and the constant tells you the y-intercept, so we can just really use those things. So if we look at number 21, 21 is a positive x cubed with a positive 6. So we know it's either got to be A or C, because those are both the positive cubic, what that shape looks like. And since it goes through a plus 6 right here, it matches with 21, where 22 is also a positive cubic, but it's got a negative x-intercept, so then A has got to be 22. And then if you look at 23, it's the same kind of process. 23 is a negative cubic like this one, and it has a positive y-intercept of 6, so you got to know 23 is that, or 24 is just the opposite. It is a negative cubic like this one, but it has a negative x-intercept of negative 6. Okay. The roots, remember the roots is just another word for 0, which is another word for an x-intercept. And we decided in class, this is a little more advanced than we currently are, but we know that if a function has 3 x-intercepts of -3, -1, and 2, then the function itself must be able to be broken down and factored with x plus 3, x plus 1, x minus 2. Remember, if 2 forces the function to be 0, then x minus 2 must be a factor. If -1, 0 is an x-intercept, then x plus 1 must be a factor. If -3, 0 is a root, then x plus 3 must be a factor, because if -3 makes it 0, x plus 3 must be multiplied in that polynomial. And so we do that same thing for all of these. If you know information about their x-intercepts, then you for sure know information about the factors of that polynomial. Okay, down here, so 25 is this negative x to the 4th. It kind of looks like this, and in this case there are no real roots, no x-intercepts, which leads us to know that there are 4 complex roots. Remember, complex and imaginary are the same thing. 26 is just some quadratic, so it looks like it's this one right here. This is just a smile. It's got 2 x-intercepts, meaning 2 real roots, so it's got 0 imaginary. C is a negative cubic, so it's 28. It's got 1 x-intercept, so then it's got to have 2 imaginary solutions. And D does, in fact, is a positive cubic. It's got 3 x-intercepts, so it's got 3 real roots, no imaginary roots. Again, we know based on the shape of it that what it looks like there, and we also know that the degree or the order is the same thing as the biggest power. Okay, this connection here about real roots and imaginary roots is really going to be tested more on the next test, as well as the connection between factors and the roots. But I think it's good to kind of look at it, before we get all the way there. All right, this one, write the end behavior and label as even or odd. Okay, this one also, it's a little more than we did in class, but, or well, maybe we were supposed to do in class, but we know that if you take an odd thing plus another odd thing plus an even thing, if you add even functions with odd functions together, you get something that has no more symmetry. You've lost the symmetry. So generally, this would be a positive cubic. It would look like that. Its end behavior we can write, but it is not odd or even. Same thing on this one. This is even, but then that's odd, and if you're adding evens and odds together, you're going to lose all symmetry. So this one, again, has no symmetry, so it is not either or odd. However, we do know, because it's a negative x to the 4th, that it does have that general M shape, and both end behaviors are negative infinity because it's going down. Now this one It's got an even, plus an even, minus an even. A combination of even functions makes the function overall even. It will have y-axis symmetry because each one of those things individually have y-axis symmetry. If it's x to the fourth, we know that's the general shape, and we know the end behavior is infinity, infinity. This one is the opposite of that. This is two odd functions added or subtracted together, and that will be an odd function. It will have origin symmetry. It's a negative cubic, so we know it has that general shape, and then we can see that as x goes to negative infinity, the function goes up, and as x goes to positive infinity, meaning to the right, the function goes down. And again, this is just me reminding you that a combination of even functions is even, like 37. A combination of odd functions is odd, and odds plus or minus evens, loses all symmetry. Okay, sketch the graph. Again, this is a negative cubic, positive x to the fourth. A negative x to the sixth looks something like this, and then a positive x to the 123rd, meaning it's odd, looks something like this. The number and size of the humps sometimes relates to the actual function, but you're not positive of that because you don't always have all the humps that you possibly could have. But you do know the end behavior, and you know the general shape of what it will look like. Okay, so hopefully this video helps you study and review this worksheet for the test.